Okay, class, just as I promised, I'm going to go through a review of Chapter 3 for you so that you can be ready for the test tomorrow. I'm even going to go through some of the questions that you're going to be asked. The first section on the test is asking about whether or not a number is prime, composite, neither, or both. Well, you should be able to eliminate both, right? A number cannot be both prime and composite. A prime number has exactly 2 factors. A composite number has more than 2 factors. But what should you do when you are answering these questions? You should go through the divisibility rules. That's the first thing you should ask yourself. Is the number divisible by 2? Is it, in other words, is it even? Then, always add the digits. The next thing you should do is add the digits to see if it's prime. If you add the digits and the sum is divisible by 3, then the number is divisible by 3. If it is the sum is divisible by 9, then it's divisible by 9. If it ends in a 0 or 5, it's divisible by 5. If the last 2 digits are divisible by 4, then the number is divisible by 4. If it's divisible by both 2 and 3, then it's divisible by 6. And finally, if it is the last 3 digits are divisible by 8, then the number is divisible by 8. So let's take one like 283, for example. It ends in an odd number, so it's not divisible by 2. When we add the digits, 2 plus 8 plus 3 is 13. That's not divisible by 3 or 9. It's not divisible by 5 or by 4 or by 8. Then the only thing we have to check is it divisible by a prime a prime number? So let's look at the list. Prime perfect squares. 200, it's not 17, it's not 13, it's not 19. So that must be a prime number, okay? What about 0? Is 0 prime or composite, neither or both? Think about it. Does it have 2 factors? Does it have more than 2 factors? No. So make sure that you know whether 0 is prime or composite. How about finding the greatest common factor? When we're finding the greatest common factor, we are factoring the numbers, and then we are, where is it? Here we go. Factoring the numbers, and then circle the common factors. That's the factors that are in both numbers, and multiplying them. Remember, if there's a 2 in each one, then you multiply by 2. If there's another 2, then you multiply by another 2. If there's a 3 in both, then you multiply by 3. All right? You multiply by the common factors. Sometimes 1 is the only common factor. So be careful of a number that only has 1 as its greatest common factor. What if you have 3 numbers? Let's say that you have 3 numbers like 12, 18, and 24. The greatest common factor. You might be able to figure out the greatest common factor just by knowing that these numbers are multiples of 6, 3, 4, all of those have that common factor, which is the greatest common factor, okay? How about a number like numbers like 54 and 63? Again, you might see a number in there like 9 and 6 going to 54, 9 and 7 going to 54, okay? And then if you factor that out, 2 and 3, 3 and 3, 7 is prime, 3 and 3, circle the common factors, and multiply. Okay? Now, when you're finding the prime factorization, make sure that when you're multiplying, if it is the prime factorization of a number, then the answer will equal the number that you're given. So, can 2 times 7 be the prime factorization of this number? No, because it doesn't equal 56. It equals 14. Whatever you choose, it has to equal this number, and it has to be all prime numbers. You can only use prime numbers in the prime factorization. Okay? Now, there's a section that says, tell whether each number is divisible by, and then it lists all of those numbers that we just covered. 2, 3, 4, 5, 6, 8, 9, 10. So you have to know the divisibility rules for those numbers. Make sure that you memorize those. We already had a quiz on that. We had a quiz on this where you had to memorize those rules, and that's why we took that quiz. Okay? Then another one, finding the prime factorization, but this time in exponential form. Then it says choose the 4-digit number with no repeated digits that fits the description. A number that is divisible by 8 and by 9. Well, one of the ways that you might have to do is just check this. Check the number and see if it is divisible by 8 and divisible by 9. But if you know the divisibility rules, you know that for 8, the last 3 digits, okay, not the sum of those, but just the last 3 digits will be divisible by 8. So for any number, let's say you have 5,380, if the last 3 digits are divisible by 8. So you can just do 380 divided by 8. 8 goes into 38 4 times. 32. 60, does 8 go into 60? Not evenly. So 380 is not, this number is not divisible by 8. Okay? Is it divisible by 9? Well, 8. 5 plus 3 is 8, plus another 8, plus 0 is 16. That number is not a multiple of 9, so that number is not divisible by 9 either. You have to find the one that's divisible by 8 and 9. Okay? Then you have to find one that's divisible by 6, but not 8. Well, if it's divisible by 6, it has to be divisible by 2 and by 3. How about a number divisible by 2, 4, and 6? Well, if it's divisible by 2 and 3, then it's also divisible by 6. And if the last 2 digits are divisible by 4, then the number is divisible by 4. So you might want to check to see if and eliminate the ones that are not divisible by 4 first. Find the greatest common multiple. That's the next section. To find the greatest common multiple, this is in your notes. You can list the multiples and circle the biggest one. Okay? And that should work for both of these questions. List the multiples by counting by each number and then circle that one. Then 24 and 25 are very similar to the pretest. If you use the same charts that I showed you for this, let's see if we still have them. Oh, I think they're here. The same charts should work for 24 and 25. Using a chart like this, but maybe you'll list Tuesday, Wednesday, Thursday, Friday, and then the times available. And if you make a web of the choices for 25, that should help you to find whether or not, what number of choices you have for 25. Okay? All right, I hope this helps. I hope you watch it, and I hope you get an A.